welcome everyone. Let's start off with our course that is Cisco SD-wan. My name is Moise Karim. So let's start off with the introduction of the SD-wan as the IT industry is constantly changing and evolving, and as the time goes on, there is ever increasing amount of technology putting on strain. So we know that traditionally we have a very limited resources for like very less people using the computer system and everything, but nowadays it's including the smartphone, laptops. Everyone has the smartphones and the laptop for their work or for their any kind of work, like for basic work or anything. Every home now has the internet and as well as the smartphone and the laptop. So new paradigms are formed as others are being shifted away from. New advances are being developed and adopted within the networking realm. These advances are being created to provide faster innovation and the ability to adopt relevant technologies in a simplified way. So when we look at to the traditional things like a decade ago, there were not many, what do we say, devices in an household, but today the devices are almost double and triple because every house has at least a laptop and a smartphone as well as the internet connection. Nowadays, the iPads and the tablets are becoming more and more famous. Now, this requires the need for more intelligence and the capability to leverage the data from connection and distributed environments. So, if you remember the decade ago, like 200 MB or 100 MB file size was like a very big thing, but nowadays to at least 15 GB, 20 GB is nothing, that's like a data. So, individual is using a lot of internet data when compared to a decade ago. So to meet those requirements, we do require a more intelligent and capability of the WAN devices in order to facilitate that one. Now, the distributed environment can be like campuses, branches, data centers, and wide area network for businesses. And in the campuses also, again, you need to have a lot of bandwidth in order to facilitate that amount of data and the speed for the internet. Now, doing so allows for the use of data is interesting and more powerful ways than ever in the past. Now, some of the advances driving these outcomes are the following. So, if you know that artificial intelligence, nowadays it's a lot of people are going into the automations, machine learning, which will learn according to your rules and everything, cloud services. Many businesses are moving to the cloud in order to save the money and keep the uh, operation cost as low as possible. Virtualization, because of the virtualization, we no need to have the physical device anymore. We can utilize the same device. We can host multiple services or multiple operating system within a one system. So that also has driven a lot of, contributed a lot of, what do we say, to reduce the significant amount of hardware required in order to host a data center, maybe on office premises or business premises. Internet of Things is like everywhere nowadays, including your cameras, your lights, your fans, and everything. It's all within an app. So Internet of Things are like a most common thing. So these are the different parameters which are driving those capabilities and requirements. These are the things which are affecting in order to have our to improve our requirements in the data as well as for the internet as well as for the security and especially for the businesses. Now, common business ID trends, the traditional network infrastructure was deployed when the security parameters was well defined. So before the, so what do we say, deploying the actual internet or whatever it might be, we were looking into the security parameters first, then we within that security parameters, you were defining your infrastructure. Now, most applications were low bandwidth, definitely because at that time the bandwidths were very costly and most contents and applications reside in centralized corporate data centers. Now, today enterprises have a very different requirements. High bandwidth, real time, and big data applications are pushing the capacity limits of the network. So, the requirement of the bandwidth is more than when compared to before. So, in order to facilitate that one, we do require a technology which can handle that kind of load. In some cases, the majority of the traffic is destined for the internet or public cloud, and the security parameters as it existed in the past is quickly disappeared. So traditionally, it says that whenever you want to access the internet, it goes via the data center only. But nowadays, we cannot do that one because going via the data center will add up some latency, and the experience might be affected by that. So we need to have some kind of robust solution for that one. Now, this is due to the surge in bring your own device, BYOD device. If you remember that all businesses nowadays are hosting or encouraging bring your own device. It's not the business laptop, it's just your own smart device. So your own smart device, you will be bringing it with you and you're connecting to the corporate enterprise and network and you are accessing the internet on your smart device. So bringing your own device is nowadays a common thing. And dynamic business to business ecosystem. The downside and risky of staying status quo are significant technologically innovations has failed to comprehensively address those problems. So it did traditional configuration, if you look into that one, it will be complex and it did fail to address this kind of security issues. Now, there has been a huge increase in the use of software as a service since the cloud has started. So software as a service, they are started to provide that one, and many people are leveraging that software as a service and infrastructure as a service as offering. And if you remember that, you can deploy your own operating system, own applications, and design it, do the networking, or do the routing and everything by yourself in order uh, to make sure that you have the more control than the cloud provider. Now, it seems as if more applications are moving to the cloud these days. That's correct. And if you remember that Microsoft 365 and the Google apps, also the Salesforce app, both all of these are the examples of the software as a service. Another software as a service based productivity and business application is not effectively addressed by traditional design that utilize internet capabilities out of one or more centralized data center. Now, basically what happens is like whenever you want to access the internet, this is the corporate business and they are connected to the internet, but they don't go directly to the internet like Office 365. In order to go to the Office 365, they have to go to the data center, and from the data center, they have to go to the application, cloud application. So this what happens is like this whole thing is now adding up a latency over here. Once it adds the latency, it will affect the user experience. So that's what the problem mainly is, because the traditional network, that is what it is being configured. So that's the reason user experience will have been is being affected because of that one. Now, the following list contains some of the most common trends being seen in the industry. Applications are moving to the cloud, that's correct, maybe a private or public. Internet edge is moving to the remote branches. So if you remember, or if you say that in order to save some money, people are moving their edge devices or data centers to the regional areas to save some cost. Now, mobile devices, bring your own device and the guest access. If you remember that if you go to any office, there will be definitely a guest access. So guests are like an extra people who are adding it to your network to access the internet. High bandwidth application. Nowadays, if you remember, example would be your YouTube. So in order to see the YouTube, like if it is a 720 pixel video, it will almost cost you 1 GB of data in order to watch the whole movie. If it is a 1080 pixel, then it will be around 2 GB. Or if it is a 4K, then it can be up to 15 to 20 GB of data. So for 3 hours movie. So the high-bit applications, yes, depending upon the application, it the demands are increasing about the what do we say for the bandwidth. IoT devices, do not require much of the bandwidth. Most of the IoT devices are still running on 2.4 gigahertz. Very less of them are running on the 5 gigahertz, which will utilize the high speed. So, but IoT devices are becoming more and more common now. So that means people are adding those devices to their home internet and everything in order to manage it remotely. Now, the desired benefit, designing and deploying the next generation WAN is about taking advantage of some very useful benefits and the impact they have on the network environment and overall experience. So we are all focusing now on overall user experience. So we shifted from configuring the traditional network to the software as a service, cloud, and all different things, and overall focus on the user experience. Prioritize and secure traffic with granular control. We can do it in the traditional also using the quality of service, but our new solutions have better ideas. Now, reduce cost and lower operational complexity. So, all traditional internet or traditional configuration is very complex because, for example, you do have sites over here, and all of these sites are connected to your data center via the internet. Now, every site is going to the internet via the data center. That side is to adding the latency. That's normal. Another thing is that if in order to from site to site communication, again, they have to configure in such a way that they go to the data center. From the data center, they will come back to the site. So it's like an hub and spoke topology. But again, that was also still good, but the issues starts from here because as the sites are keep adding and you want to communicate site to site and site to site, that means you will be creating your VPNs. If you're creating your VPNs, then you are doing the encryption. So if you are doing the encryption, then you have to monitor it. So the network configuration is becoming complex and complex. Because of that one, you have to have many different types of monitoring systems. Right, so because of this different types of monitoring system, you don't have an actual like a visibility, the whole visibility. So the whole network visibility, you don't have it because if anything goes wrong, it will take days to troubleshoot the problem. If something has to be configured, it will take days to be configured. And for example, like customer has ordered like there is one branch connected to your ISP, and from the ISP there is another branch, and customer has ordered one tunnel saying that he requires a low latency tunnel. So you have given him a path low latency that is been configured, but after a while he doesn't require that one, so he will stop paying for that one, but still that path it will be configured and it will be there because what is been configured you do not touch it. And to do the maintenance it will take again a lot of time. Now, augment or replace premium WAN bandwidth. So the idea of the new solution is that to replace that expensive MPLS links, because MPLS links will cost you a lot of money if you are using a very high bandwidth. Provide a consistent high quality user experience, offload guest and public cloud traffic, ensure remote site uptime. So these are the benefits with the Cisco SD-WAN or new solution you can say. Now, with the desired benefits, what are the different things which will be affecting your network? Like you have a single failure link, you know that you have a single failure link and you can go ahead with the multiple links connected to the internet. If you have all failure links, then again you do have a different type of setup where it will be traffic will be diverted via some other way, like LTE or 4G or 5G. CP device failure, if the device itself is failure, then again you do have like an active standby or an active configuration at your premises. Bandwidth oversubscription, you can implement quality of service, but again high bandwidth nowadays, internet 1000 Mbps is nothing. It will cost you around $300 only. So the bandwidth is now much cheaper when compared to previous like a decade ago. Path burnout, path MTU changes, static topology. Again, topologies means you can configure anything. Cloud application latencies, again, it all depends upon you how you configure uh, the branch devices to access the cloud applications. So with the new solution, there are many benefits because we do have many alternative solutions in that one. Now, the solution requires to support the solution should be in such a way that it requires to support today's cloud-enabled enterprise, need to be complete and comprehensive, should be based on software-defined approach. So software-defined approach means you are less managing your network. So basically, you can say that automation. So somewhat of the configuration will be automation so that you do have some visibility and everything, like monitoring system. So you need to have a solution which will give you an automated monitoring system. You don't have to worry in order to configure those monitoring systems. The solution must be include a robust set of capability that reduce cost and complexity as well as promote business continuity and rapid innovation. The capability should include the separation of management plane, control plane, and data plane. So again, in the traditional way, if you look at the hub and spoke topology, now management plane, control plane, and the data plane all lies on the same devices itself. So if you want to manage the devices, you will access the device using the management plane, which will relies on the same device. Control plane means the device itself is making the decision how to forward the packets and everything. Data planes, he will know that the device itself is doing the path lookup and everything and forwarding the path. So we need a solution which separates the management, control, and data plane. So this will provide more horizontal scaling capabilities and the security knowing where the data is at all times. So when you separate the management plane, control plane, and the data plane, that will give you a lot of flexibility. So when you add a new device, you don't have to worry about it. Now it should provide various consumption models such as being hosted in cloud or being managed on premises. So whatever might be the solution should be capable of automation, number one. So number two, that means it should be flexible in connecting to the cloud or connecting to your branch to branch connectivity. Irrespective of that one, in any way, it should be like the model or solution should be in such a way that the managing should be so good that you don't have to worry about it. The solution must also provide a complete set of network visibility. As I said, monitoring is very important and you need to have a complete set of monitoring visibility of your network. If you don't have the visibility of your network, then things become very much complex and you don't know how to troubleshoot the things, how to start, where to start, and how to get it there. All right, visibility and troubleshooting tools that are all accessible from a single place. The main thing is that you're getting the visibility, so you're getting the management access, and you're doing the troubleshooting all from one single plane. From a single device, you're doing these many things. So that solution would be like it will transform your business requirements, network, troubleshooting, monitoring system, and everything. So this is the solution which today's business requires. Now, common desired benefits, faster branch deployment with no operational interaction. So that means if there is already what do we say, a network in place, when you add a new device, they should not have much problem in that one. So traditionally means you have to configure this device to be via the CLI, and again you have to make sure that all the branches are able to communicate with these branches. So a lot of manual work. We don't want to do that manual work. We want a solution which can have an automation. Increase WAN performance, topology independence. That means if it is two devices or branches, you can say that should be participating in a hub and spoke, while other devices should be in a mesh topology. It should support this one because traditionally, if you see that hub and spoke, that should okay, but when you trying to mesh different branches, that's where the problem again starts in because you are configuring this whole network's branches in the mesh one, and again these three branches are in the hub and spoke topology. That means again these routes should be propagated to the data center. It should have the connectivity as these routers branches are able to communicate via the data center only. So the solution also includes the topology independence and better user experience. Now the today digital transformation, so we are moving from hardware centric to the software driven definitely because Cisco SD-wan solution itself is a lot of automation. Now, in automation, in a sense, like when you connect a device to your internet, it will automatically go to your account and it will automatically register it and it will automatically download the configuration from your management device. So before the traditional it was manually, nowadays we are becoming like automated and again software driven. It's just like a built-in nowadays in the device itself. Now, before it was a closed because whenever we want to do the troubleshooting, We have to do it via the CLI, or the network engineer was able to do it, but nowadays it's a programmability like using the APIs. So everything is been configured for you. The only thing is that you just need to enable those features and use those features. Now reactive, before it was the reactive one, now we are going to the predictive one. So in a traditionally, when I want to configure anything, if I like, for example, I want to add the configure this type of topology, I have to predict, not the reactive in a way, not in a predictive way, in a reactive way, like if I configure in this way. So I need to have a stimulation first. What is going to happen when I configure this one? How is going to be act? It's going to act or react, or maybe how it's going to behave. From that, we are now moving to the predictive one. Now we know that we how it will behave when the device is connected. We don't worry about those things nowadays. We worry about the predictive one, how we are, like how we are using the services, which application is a top application, and how we can improve the user experience. So we can now predict that these services have been used a lot and we have to make some improvement in that one. Now, before it was a network intended, now it is a business intended. So network definitely, because it was manually configured, manually maintained and everything. So that's the reason it is network intended. Nowadays, it's like a business. According to the business requirement, you are changing your whole configuration or the topology, because nowadays everyone is going to the cloud. So you're having an hosted on premises and you just decided to move to the cloud. Now you're slowly starting all the services to move to the cloud. Once it is moved to the cloud, you are just shutting down the on premises. So the business requirement is that moving to the on cloud is saving money, and not maintaining this hardware is saving a lot of money. So in both ways, business requirements are meeting, so that's why they are moving. So in today's world, we are, according to the business, we are going to provision the network. Now, the solution which we discussed previously, Cisco SD-WAN gives all of them, shifting from a network-centric model to a business intent-based WAN network representation, a significant change. This new approach simplifies application deployment and management by focusing on application service rather than on network topology. So network topology, that means again with the SD-WAN also you will configure the hub and spoke, for example. But in the now what we are going to do, when you add a new device, you don't have to worry about it because everything is being done on the management plane. So in the management, whichever the device, the component will be responsible for pushing the templates, pushing the configuration and everything. You are configuring over there and it's everything is being ready over there. You just need to connect to the internet. Once connected to the internet, it will do its process. It will go to the, it will reach out to that device. It will download the config and automatically it will configure the device. So we don't have to worry about the network topologies. We just worry about our application where we host on your data center. So we are worried about the application, how it's going to be reachable, how it's going to be improve the user experience. However, it requires a mindset to shift from a network operations staff who must support applications that consume large amount of bandwidth and are sensitive to jitter loss and delay. So now traditionally all these configurations have been done by the CLI, so network engineers and everything. But we need to have a mindset in order to move to the software-defined networking in order to utilize these kind of benefits. Nowadays, the applications are now depend on the bandwidth, so we measure the bandwidth with the jitter, loss, and delay. Because we do have a multiple paths, so definitely we will create an SLA saying that if this SLA does not meet or it's been breached, you go to the other, what do we say, the link, or if any of the link is better than this SLA, just go with that link. Now, cloud-based applications like ERP, CRM increase bandwidth demands, making it costly and difficult to provision new service with traditional connectivity options. So, again, when you have a more applications which are demanding a higher bandwidth, means you're paying a lot of money in a traditional way because you will be using the MPLS link for dedicated links. But nowadays in this Cisco SD-WAN, you don't have to worry about it because it has the security on the normal business. The data is not being leaked or breached, so it will be secure to access to host the application just like that. Business often rely on the service provider MPLS L3 VPN, which can be slow and expensive to adapt a new application delivery method like cloud and SaaS. As I said that MPLS are very much expensive and dedicated, so it will take time to implement as well as it is expensive. So now this Cisco SD-WAN solves that problem. Now this is why the concept of hybrid WAN was or originated. So because the demands were increasing as the technology evolves, so hybrid WAN was implemented, like invented or discovered. Hybrid WAN was implemented. Again, hybrid WAN means same thing, connecting to your on-premises device to the cloud. But the only difference would be that in the traditional, everything goes to the data center via the data center. Now, hybrid WANs provide the business with the alternative paths for application across the WAN environment. So you do have the business internet going to the data center from here, then again connecting to the cloud, or you just directly go to the cloud, direct cloud access or the application access. So you do have two different paths. So if you have multiple paths, you can utilize those paths in order to communicate with your application. Now, hybrid brand provide business with alternative paths for applications across WAN environment, giving that complete control. So this will give you complete control over routing and application performance. So you are now having multiple path means you are now defining the quality of services, maybe a policy, maybe an SLA, which is a requirement, and depending upon that requirement, you are taking the action now. So it's like a full granular control by using various types of link like broadband internet. So you're using the LTE nowadays. So in case like MPLS is also down or the internet is also down, so you can utilize the LTE service or the 4G service or the 5G service also. This allows to secure VPN tunnels over many links, ensuring deterministic routing and application performance. And the this we will discuss more in detail later on, the VPN, because how the data is being secured over the WAN is important. You need to know that how Cisco SD-WAN secures using the tunnels. Now, Cisco software defined SD-WAN, as you can see that this is like an just a topology where you can see that they have two links connected. One is MPLS or internet. They can have a mix and match like MPLS or 4G or LTE or internet or 4G LTE. Just like a mix and match, you can have any multiple links connected or multiple paths in order to communicate with the branch to branch or communicate with your cloud applications. Cisco Software Defined uses a transport independent fabric technology to connect remote locations via the overlay network. So we are going to discuss about the underlay and overlay later on. But the main thing is that it is transport independent. That means your what do we say, branch device is connected to the ISP, connected to the MPLS, and connected to the 4G. All three are independent. So it has nothing to do with why each another. Every link is an independent link. So that means if anyone goes down, all both the remaining two are up, and so you can divert your traffic via the MPLS simply. Now this concept is known as transport. So this overlay tunnels traffic over a transport type, enabling flexible routing application regardless of underlying circuit. So let's take a small example how things work. So this is my branch device which is connected to the ISP, and there is another branch device. Now connecting to the ISP doesn't mean that it is directly connected to your ISP, right? There will be a company called which will be providing you the underground cabling. So there will be a company or a organization which will be providing the underground cabling. So it's like connected via the ground to some other circuits and everywhere, multiple circuits, and it is connected some kind of pits and everything, and finally connecting to your ISP. And the remote branch, the other branch is also the same. Again, it is connected to the ground cabling so and so and connected to your ISP. So this whole thing you don't need to worry because someone else is managing for you so that you have a direct connectivity to your ISP itself. So even though you're connecting to this underground cabling, but your connection in such a way that it is directly connected to your ISP. Now on that, since these two branches are able to communicate via your ISP, so Cisco SD-WAN will build a tunnel, and that tunnel is called as an overlay tunnel. So underlay will be connecting to various paths, whatever it might be, we don't worry about it. But once we have a connectivity between two different branches, we just create a tunnel. And now, logically, if you see that one branch is connected directly to the another branch via the tunnel. So physically, it's connected via multiple, like a whole different way, but logically, like an overlay, it is directly connected to each other. This concept known as a transport independence ensure that every remote site is just a single hop away. So definitely because of the tunnel, the next remote site is only like a single hop away, improving application latency and dynamic communication scenarios like voice or video. So this will give an ability because the tunnel is already there, the application is hosted over here, and we already know where the hosted applications are. So the device, when it knows where the application is, it will just directly go to that particular device. No need to look up and everything. So the user experience will increase. The primary benefit of Cisco SD-WAN is its ability to use lower cost, flexible commodity circuits instead of expensive static bandwidth options. Now this reduces the cost and simplify the network operations, providing seamless mobility and better user experience. That is true. However, upgrading bandwidth through service provider can be costly and time consuming, often requiring significant changes to the physical circuit. But with the SD-WAN now, we don't worry about it. If you are currently on 500 Mbps of speed, you can just go ahead and increase your 100 MB that to 1000 Mbps of speed simply. We don't need to make any changes on either side. So only your service provider will increase the shaping, but on your side, it's nothing changed. Now look at this particular example where there is a Cisco SD-WAN device at the edge, and inside they are different services connected. Now to the LAN, they are connected to your PCs, maybe your computer, desktop, and everything. Wirelessly, they are connected to your uh, via your like on the wireless, it will be laptops, mobile phones, tablets, and everything. And you do have applications in hosted somewhere in your same branch, maybe on your data center. So it's like IoT of things and everything. So businesses also have the IoT of things. Now, you see that these are the Cisco SD-WAN devices which are connected to the whole fabric over here. Now, irrespective of the connectivity, whether it is connected to ISP, MPLS, or 4G or 5G, irrespective of that one, but whenever the user wants to go to the cloud delivered application, it can go directly to it. If it is want to go to your ISP, go to the access to the internet, it can go directly. Or if it wants to have a site-to-site communication, it can go directly because of the overlay tunnel. The other site is only single hop away. Now, this gives the benefits like since every branch is single hops away, you don't have to worry about the latency, like almost the latency will be very, very low. Oh. Now, because of this one, you do have a lot of benefits like integrating your DNA center solution into this one, maybe implementing the eyes for the authentication of the granular segmentation of the users, authentication and authorization, a AAA server, and also you will get automation because these devices are automation. Means if you add one more device and it is connected to the internet, it will get an IP address simply, and it goes to your particular authenticating device and it will authenticate itself, and it will go to the provisioning device, onboard the device, and after that it goes to the management where the device config might be ready and it will just download and it will be ready to up and go. So maximum is like 2 to 5 minutes it will be up and running simply. Now because of these things now there are a lot of benefits. Now you do get the analytics for the monitoring and visibility, so you can predict the things now, which application is your critical one, So you can see that the critical application, which branches are using, how many users are using, how much data is being used, bit bandwidth is being used. So according to that one, you can see that if there is any packet loss, like latency issues going on, so you can just increase the bandwidth for that particular application, right? Or whether it might be hosted on your data center, maybe on your cloud, infrastructure as a service, software as a service, or virtual data center, irrespective of this one, you will just increase the bandwidth to make sure that they have a low latency and a good user experience. Now, SD-WAN on cloud ramp, you can just, there is an option on the SD-WAN, you can just click on that one and connect to your cloud simply. And there are a lot of different use cases which we are going to discuss later in this video series. Now, Cisco's software-defined networking, again, as I said, fabric independent. This is for the transport. Transport means we use the broadband, MPLS, or the cellular. And again, we do have a zero touch and zero trust. Zero trust means you're not making sure that the device is authenticated. After authentication itself, only we will provision that device. So that's the orchestration part. So where the device is being connected to the ISP, so it do the authenticate itself, and it will do the onboarding process. So once the onboarding is process is that, it's ready to connect to the internet itself, and it's ready to connect to your site-to-site communication. So once you have this data flowing from the inside the networks, so data is now flowing up. So once the data starts flowing, the monitoring system. There is an inbuilt monitoring system for you. You don't have to worry. You just select the particular branch and you can see the routing, security, segmentation, quality of service, or any service you have inserted in that one. So there are a lot of different options which you can do it from your single pane. From a single dashboard, you can monitor it, you can provision it. And V Analytics is something like connecting to the Cisco cloud. So it's like another feature. So analytics is different, but I'm talking about the V Analytics. So analytics means just getting the details of you. If you have configured the SLAs, you have done the traffic engineering. So these many things, you will get the information about that one. But with the V Analytics, what happens is like it will get those information into the cloud. It will run some machine learning things and it will show you these suggestions. So according to the suggestions, you can improve your services, application, user experience, and so on and so. So V Analytics is a little bit different, but analytics is just getting the data in, and you are able to get the visibility of it, what's happening, but you're not able to compare that data or put it in a single chart. But V Analytics, it will give you an ability to compare the data and see what's going on in your network. Now, Cisco software-defined networking demanding changes in the WAN. So it can be many changes in the demand because now you're not worried about the configuration change. You are just worried about your applications. So according to the user experience, you will just change your decisions now. So basically, pre-session load sharing, the default will be a load sharing in the Cisco SD-WAN. So if you like, you can manipulate the routes in order to utilize the less expensive bandwidth, or you can say that for your critical application, MPLS should be always active and the internet should be a backup. Or you can just define an SLA. According to that SLA, it will decide which link is good and which link is not good. And obviously, MPLS is a dedicated one. That means it's always have a low latency. But what you can do is that you can define an SLA. You can say that whenever the internet is there, you prefer the internet. Okay. If certain limit has been crossed, then you go to the MPLS. So you will define the SLA, and according to the SLA, you're telling your device to make a decision on. Now, demanding changes in the WAN, protecting critical applications with the SLA as we discuss. As the SLA changes, like latency is 150 millisecond to loss should be less than 2 seconds and data should be less than 10 milliseconds. So if these requirements are met, it will take the path 1. If the path 1 doesn't meet, then it will take the path 2, that is MPLS. If that one also doesn't meet, then it will take the 4G or LTE. But whatever which one is the better, it will take that path. So it all depends upon the SLA which you define and the policy. Now end-to-end segmentation. Now this is where things are very much interesting. So you do have your branch device which is now connected to your internet. End-to-end segmentation, you have one more branch, branch 2 over here. So now you do have the corporate employees and you do have the guest. And again in the branch, you do have the corporate employees, you do have the services or applications, and you do also have the guest over here. Now, when we have this branch to branch connectivity, that means there is a tunnel with a single hop. So segmentation works in such a way that every, what do we say, the LAN service is been associated with a VPN and VPN number. And this just simply implies to the VRF. So this branch device, when this Ethernet is connected to the corporate switch, that means you are assigning some sort of VPN number to it. So that means it's just creating an VRF. So it's entirely a different router now. This part is a different router. Similarly with the other thing, guest one is also a different router. And the links which are connecting to your internet also is a different router. So you're breaking one router into a multiple routers. Okay. So now these two corporate employees and the guest users cannot communicate with each other because they are associated in different VRFs with the different numbers. Simply. So now what happens is like when the corporate employee is trying to reach to the internet, it is going via the outside the VRF which is connecting to the internet. But the concept of VRF is such that one VRF does not communicate with each other. So there is a mechanism in the Cisco that will do automatically for you, like taking the routes of this VPN 10 and inserting into the VRF which is connected to the internet. So we will say that this is VRF number 0, this is VRF number 10, and this is VRF number 20, VPN number 20. So what's happening here is that the VRF leaking is taking place automatically. So it is this device is capable of doing automation, taking these routes and leaking it to the internet facing VRF. So I do have one device. I broke it into 3 devices, but still I'm able to communicate seamlessly without any issues because Cisco SD-wan, the device itself is doing a lot of things for me. Now think about the same scenario if you want to do via the CLI. You have to do a lot of configuration in order to leak those information to one VRF to the another VRF. But here we are not doing anything, it's been done automatically for you. So seamlessly they are able to connect to the internet, but they are also simultaneously they are also not able to communicate with each other. Now let's look at an example like VPN 1020. So if you see here VPN 1, 2, 3 different VPNs, we are packing all those VPNs into a single tunnel. So that means in my case that is VPN 10, this is VPN 20, and I am packing this whole thing into a single VPN 0, and whenever they are going to the outside world, or if it is going directly to the internet, that's fine, but it is trying to communicate with branch to branch, then there is a tunnel, and this tunnel is an IPsec tunnel. Okay, so if it is going to the internet, that's all good. But if it is not going to the internet and going to the branch device, so it will go via the IPsec tunnel. So over the internet, normal internet, which is open, everyone can capture the packets. But since this is an IPsec tunnel, that means your data is being encrypted. So you don't have to worry about it. So this diagram depicts similar thing what I told you now. So you have a lot of VPNs at the back of your router, but that whenever it is going outside, it will be what do we say, the traffic will be passed via the IPsec tunnel depending upon where it is being destined to it. Because the IPsec tunnel, if you cannot configure with the internet, right? Because in the internet there are a lot of things. So if it is going to the internet, the device will be responsible to translate that one and get the information. And the security is being taken care by the device itself. But if it is a branch to branch communication, this is where the packets are forwarded. So that's why it will create a tunnel in order to connect each other in a single hop. And also that tunnel will be encrypted by the IPsec tunnel. So there is a lot of security in there. So I hope you understand this one. Now, direct internet access. So traditionally what happens? Again, going to the data center, from the data center you're going to your different applications. But now the requirements have been changed. So this is your branch device. If you want to go to Office 365, you don't have to go to data center. You can just simply allow them to go to connect to the Office 365. Or if you like, this one might be a normal ISP or ISP1. So this can be an ISP2. So you can say that, okay, when you want to go to the Office 365, go with the ISP1 because that has 1000 Mbps. And if you want to go to Google or Dropbox, just go with ISP2 because it has a 200 Mbps of speed. And if you want to go via the Salesforce, again, you can go directly via the ISP1 or ISP2. Simply, you have an option. But if you have implemented an SLA, then it will see that which link is better, and according to that link, it will make a decision and forward your traffic. Now, when evaluating let's understand the return on investment, that is ROI. So before, traditionally what happens is like businesses purchase the devices, they will just like an approximate value, how much it is going to cost. They will make a lot of calculations, but they don't do any calculations for the return. So how much they are investing, whether they are getting or not, is they are getting the return back or not, they don't worry about it a lot. They are not much worried about it. Okay, so they like what can I say? Like they do not calculate whether we are going to get the return investment or not. There is no calculation for that. But with the Cisco SD-wan in place now, you can calculate the return investment. And we will look into that one in an example. So now when evaluating Cisco SD-wan, it's crucial to build a quantifiable return on investment. So you need to build this one in order to, so you cannot just go ahead and implement your Cisco SD-wan without thinking that how much you are paying it, how much you are investing it, and whether how much you are getting in return or how much you are saving money when compared to your existing network. So business often find that replacing expensive link with a high-speed commodity internet link reduces WAN cost while adding redundancy and resilience. So now, as I said, the requirement can be a business internet, that is your normal ISP. So the MPLS. So MPLS is like maybe you're paying $1,000 or maybe $10,000 per month. But business internet is like you're getting a higher bandwidth for only $300. And you're getting like almost 1000 Mbps. So what you can do now is that instead of having MPLS, you reduce the bandwidth in MPLS and go back to $1,000. And instead of your having one ISP, you go with the two different ISPs with 1000 Mbps of speed. So now you do have 2000 Mbps of speed, and you're just paying only $600 for that one, and you're paying only $1,000 for your MPLS. That means $1,600 per month instead of paying 10,000 plus the ISP. So you're almost saving like 85% of money. So it makes a lot of difference. Like you can calculate, see the return itself here now. You're seeing the return now. If you invest in that one, you're paying something, but you're utilizing the return in a different way. Now, these benefits are typically not realized before adopting Cisco SD-WAN. Many companies offer ROI, free ROI models, making this step almost mandatory. Now, people are thinking in different way now. They used to just invest and just leave it if they got a return or not. That is not being calculated. But now we are calculating once what would be the benefit, how much we are saving actually, how much we are investing, how much we are saving. That depends on that one. You're making a decision, business decision. So that's definitely a drastical change. Some customers have experienced significant cost saving and bandwidth increase, completing the project without additional cost. Now, this is an example as I explained before, like note that staggering details of 64% of the cost saving from moving from MPLS links, from dual MPLS links, the design to a dual internet link. So you're just having a single MPLS link and dual LTE and the internet dual links. So you're having three different links and it's still costing you less when compared to the MPLS dedicated one. So I've taken an example like a real-time example, how much we are saving that much. But here also you can see that in a yearly basis, you're saving a lot of money, almost 64%. If you just move from MPLS, cut the bandwidth of the MPLS and that increase it in your normal internet, that will cut a cost of almost like 50%. So that will make a lot of change if you just move from MPLS to the business internet. So at the very least, this proves the exercise is worthwhile to complete prior to getting started with implementation and deploy. Okay, so that should give you a reason to calculate that one and move to the Cisco SD-WAN. Now, cloud trends and adoption. Cloud options have significantly increased, expanding from music and storage to SaaS and infrastructure as a service. Many business functions, including application deployment, development, and production, now run on the cloud. So that's correct because in the cloud itself now it is inbuilt. So it's all inbuilt app development process. So I think that is CI/CD pipelines, which has already been built that is connected to your GitHub, where there will be a code and GitHub will control the code versions and these versions will be synchronized with the CI/CD pipelines. And in this CI/CD pipelines, you will deploy it. So once you deploy it, it will go to the testing environment. If any bugs have been found, testing is being failed, so it will go back to the initiation session, that is deployment. Then if the testing session is been passed, then it will move to the production. So Cisco, I think there is an Azure CI/CD. There's something there like CEO. Let me search for that one. Azure CI/CD pipeline that is known as the DevOps. So Azure DevOps. So they are multiple clouds now provide the DevOps option where the developers can develop the application, do the testing, and then push it to the production side. So it's like an automated process built in by the cloud providers nowadays. Now, company often use multiple cloud vendors requiring unique policies and operational skills for each other. So is it possible that your business can be using a different cloud? Maybe a Google, maybe a Cisco, or maybe an Azure. So it is definitely possible you can use multi-cloud. This complexity is compounded by shadow IT, where department use cloud services without IT oversight, raising security and privacy concerns. So you have to be careful when connecting to the multi-cloud because individual cloud provider has the security in place, and accordingly you have to make sure that you meet those requirements in order to save your data. Now, when the complexity increases, it is compounded by the shadow IT. That means you're not actually implementing the security, not getting all the visibility, or putting an interest on that one to actually get the real data. Now, where the department use cloud services without IT oversight, no visibility, raising security and privacy concerns. So definitely when there is no visibility, you don't know what's happening and how much data the provider is looking into your actual production data. Now, Cisco SD-WAN helps manage these challenges by ensuring applications receive the necessary priority and treatment. So there is an inbuilt process for you. You don't have to worry. So it will automatically ensure that when you're connecting to your cloud, it will have the default SLS place in place, and according to that, it will make the decisions for the path. And there is also default security policies implemented for that. So you don't have to worry about it. So necessary priority and treatment, improving user experience and maintaining security. So Cisco SD-WAN has done it for you, automation. Now demand for the internet-based application have been increased a lot. So best example will be the YouTube. So without YouTube, there is no one nowadays. So without YouTube, I don't think so. Hardly many people will not be using the YouTube. Alright, so each and every device nowadays, if it is an Android device or iOS device, all the smartphones now have the applications, all the different applications are using the WAN internet. So the requirement or the demand has been increased a lot when compared to a decade. So campus branches and users, again, the students will have their own PCs, own laptops, smartphones. Then again, you have your campus PCs, staff laptops and everything. Then again, you need a high requirement of the bandwidth for the internet because they are going to connect to their private cloud for the applications for the campus, or if they have a software or the where the application is being hosted, then again, they have to access via the internet itself only. Now, businesses can be implementing the infrastructure as a service, like their own network on the cloud, implementing their own network, and again, they need some sort of communication that is internet in order to connect to those services. Okay, cloud trends adoption. So again, as I said that when defining the SLS would be the best example because if we can see that Internet 1 does not meet the SLS, then it will not take that part, but it will take the part which is Internet 2. Now, when coming to the same diagram now, when it is preferring to the Internet 2, if you see the previously, we do have a two ISPs, ISP1 and ISP2, but the same diagram or the same topology can be like ISP1 via the normal ISP, ISP2 via your regional hub or data center. So you can see that there is a possibility that you are directly connecting to the internet, your latency might be high, but the latency via your data center or the regional hub might be very less, and the site device will make a decision that according to the SLA policy which you made, the data will be forwarded on the best SLA one. So this is the one which is matching, and it will pass it on to this particular link instead of going directly to the internet. So this is a benefit. It's not always compulsory that you should be having ISP1 and ISP2. You can configure your topology as you wish because everything is being connected to the SD-WAN. All the branches are connected to the SD-WAN. So they are like only one hop away. So this one hop tunnel is making a lot of changes because it will improve the latency in your network. So it will see that, okay, directly going to the internet because ISP can have some kind of issues and they can run into loss or latency. But when you're connecting to your regional hub or data center from where you have an high speed internet, you can utilize for a while until this comes back online. So I hope the introduction for the Cisco SD-WAN is now very much in detail. I hope you have enjoyed this video and thank you.